Welcome back to another lesson, everybody. Before we begin, I just want to say thank you to everybody who has been here all along, everybody who's subscribed, everybody who's liked, commented, watched. I do appreciate it, and I thank you from the bottom of my heart. Please, if you haven't already, please subscribe to the channel. It helps me to grow, and it's also free. It costs you nothing to hit that subscribe button. So today is the very last lesson of Basic Math 1. After this, we will be on Basic Math 2. Stay tuned for the Basic 2 announcement video. That'll be more of a description of what to expect in Basic Math 2. But today we are going to convert fractions to decimals part 2. So what does that entail? Well, you have 1/2 as a fraction. How would you convert that to a decimal? Well, if you can, the biggest thing you want to do is get the denominator to have a power of 10, such as 10, 100, 1,000, what have you. So let's start with 10. Does 2 go into 10 at all? It does, 5 times. So if you multiply 2 by 5, you'll get 10. So the denominator will become 10, but of course, since we've done it to the denominator, we got to do it to the numerator. 1 times 5 is 5. Alright, so 1/2 equals 5/10. Now we need to convert that 5/10 into a decimal. So what you'll do is you'll take your 5 from the numerator, put the decimal point right after the 5, and now you have 1 0 in your denominator, so that means you'll move the decimal one place to the left, giving you an answer of 0.5. So yes, 1/2 equals 0.5. And I got more. Let's say I have 1/4. Well, does 4 go into 10? Certainly not. But does 4 go into 100? Yes, it does. If you multiply 4 by 25, you get 100. So we'll have the denominator being 100. Now, of course, we have to do it to the numerator, so 1 times 25 is 25. You will have a fraction of 25 hundredths. Now we want to convert that fraction to a decimal. So you'll take your whole number 25 from the numerator, put a point after the 5, and you see 2 zeros in the denominator, which means you need to move the decimal place to the left 2 decimal places. So 1, 2. So your answer to this is going to be 0.25. So yeah, 1/4 equals 0.25. And these fractions we're doing today with the decimals, these are good to commit to memory, like what 1/2 equals, what 1/4 equals, so on. It's going to be a nice shortcut for you. It's going to help you as you get into higher maths. Okay, we got 1/5. Does 5 go into 10 at all? Certainly does if you multiply by 2. So 5 times 2 is 10. You have a denominator of 10. You also got to multiply the numerator by 2. So 1 times 2 is 2. You now have the fraction 2/10. So in order to convert 2/10 to a decimal, you'll take the 2 from the numerator, put a decimal point right after the 2. Look how many zeros you have in your denominator. You have 1. You need to move the decimal point to the left 1 decimal place, which will give you 0.2. And that would be your answer for 1/5 is 0.2. Alright. So let's say we have 1/8. 1/8. Does 8 go into 10? No. Does it go into 100? No. Does it go into 1,000? Yes. If you multiply 8 by 125, you'll get a denominator of 1,000. So we also got to do that to the numerator. Since we've multiplied the denominator by 125, we got to do that to the numerator. Well, 1 times 125 is 125. Okay. Now we want to convert that 125 1,000ths into a decimal. So you'll have 125, you'll put the decimal point right after the 5. We have 3 zeros in the denominator, which means we need to move our decimal place to the left 3 decimal places. So 1, 2, and 3. So your answer to this will be 0.125. So that's the value for 1/8, 0.125. So all the fractions we've done so far are good to commit to memory. Now what about 31/50ths? This may not be one you commit to memory per se, but it's good for demonstration purposes. 50 goes into 100 twice. So if we do 50 times 2, you'll get a denominator of 100. But we also got to multiply the numerator by 2. 31 times 2, well, that's going to be 62. Alright, so we have converted that to 62 hundredths. Let's do the conversion to a decimal. Take the numerator, 62, put the decimal point right after the 2. Now we see 2 zeros in the denominator. That means we need to move the decimal point 2 places to the left. So 1, 2. So your answer is going to be 0.62. That would be the value for 31/50ths. I got 3 more examples here, and these next 3 are very different. Let's say you have 1/3. Well, here's the thing about 3. We know 3 doesn't go into 10, or to 100, or to 1,000, or in fact any power of 10 evenly. When that fails, you have no choice but to do long division, which we will work out on the side. So we have 1 divided by 3. Alright, so let's do a 0.1, let's do a 0.0 rather in the dividend for this equation. Of course, I better put the decimal point right above in the quotient area. Alright, now 3 goes into 10 how many times? 3. 3 times 3, that's 9. 10 minus 9 is 1. We have a remainder of 1. We want to get rid of that remainder. So let's add another 0 in the dividend, and let's bring down that 0 from the dividend. 3 goes into 10 how many times? Well, 3 times. 3 times 3 is 9. 10 minus 9, that's 1. We still have a remainder of 1. Let's add another 0 in the dividend and bring down that 0 from the dividend. 3 goes into 10 how many times? 3 times. 3 times 3 is 9. 10 minus 9, well, that's 1. Well, I think we're starting to see here we can infinitely keep adding zeros in the dividend and come up with a remainder of 1. Unfortunately, we're just going to have a repeating pattern of 0.333333333 all the way to infinity. How you would express that? How you express a number that doesn't stop, like a decimal that doesn't stop and it keeps repeating? You'll have 0.3 with a bar over it. That bar indicates the number repeats, it doesn't stop. And a number that doesn't stop, it keeps going, is called non-terminating, because if it terminates, it stops. Non-terminating means it doesn't stop. And it's a repeating number also, which means that 3 keeps repeating all the way to infinity. That's what that bar is for. And then if it was non-repeating, it would be something like 1/2. It would be something like 0.5 or 0.75. That would be an example of non-repeating numbers and terminating. But this is a non-terminating repeating number. So 1.3 is equal to 0.3 repeating. But I got 2 more. This time, let's do 2/3. We'll have 2/3 for our fraction. Again, the 3 doesn't go into 10, 100, 1,000, or any power of 10 for that matter, so we are stuck doing long division. We will have 2 divided by 3. So 2 divided by 3. Let's go ahead and do a 0.0 in the dividend. Put the decimal point up above in the quotient. 3 don't go into 2, but it goes into 20. So 3 goes into 20 how many times? 6 times. So 6 times 3, that's 18. 20 minus 18, that's 2. Well, looks like we have a remainder of 2. We need to try to get rid of the remainder. Let's add another 0 in the dividend. Bring down the 0 from the dividend. You have 3 goes into 20 how many times? 6 times. Alright, so 6 times 3, well that's 18. 20 minus 18 is 2. Still have that remainder of 2. Let's add another 0 in the dividend. Bring down a 0 from the dividend. 3 goes into 20 how many times? 6 times. 6 times 3, that's 18. 20 minus 18 is 2. Well, we can't get rid of that remainder of 2. We certainly can't. So the 0.666666666, it'll go on to infinity. So your answer is going to be 0.6 with a bar over the 6 to indicate that it repeats. So yeah, the 6 is this is also an example of a non-terminating, meaning it doesn't stop, and a repeating decimal. It just repeats on for infinity. I got one more example, but the 1/3 and 2/3 are good to commit to memory. That'll also be a nice shortcut for you. 1/6 is kind of iffy. You can if you want to commit to memory. You don't have to. I personally would, but alright, so we got 1/6. Does 6 go into 10? No. Does 6 go into 100? No. Does 6 go into 1,000? No. In fact, it don't go into any power of 10 evenly. So again, we're back to the drawing board with some long division. Well, we will have 1 divided by 6. Let's put a 0.0 in the dividend. Bring up the decimal point of the quotient also. Now 6 goes into 10 one time. 1 times 6, well that's going to be 6. 10 minus 6, well that's 4. We have that remainder of 4, which means we need to tack on another 0 in the dividend and bring down that 0. Now 6 goes into 40 how many times? It goes in 6 times. 6 times 6, well that's 36. Alright, so 40 minus 36, that's 4. Still have a remainder of 4. Let's tack on another 0. Now we can bring down put another 0 in the dividend. Let's bring that 0 down from the dividend. 6 goes into 40 how many times? Again, 6 times. 6 times 6 is 36. 40 minus 36, well that's 4. And in fact, you're going to see, if we can keep on doing this to infinity, you'll have 6's going to infinity. So your answer to this is going to be 0.1. Then you'll put a bar above the 6. So it's 0.16 repeating. Because the 6's will go on for infinity forever. So that's really all there is to that. Is if you have to, if you can't get it to a base of 10 in the denominator, do your long division. And if you have a repeating number, put a bar over the number that repeats so to indicate that. And that's really all there is to it. Alright, well everybody, it's been real fun here in Basic 1. Stay tuned for the Basic 2 announcement video, and I will see you for that video. Everybody have a good night. Thank you.